In this video, I just want to do a quick review of scatterplots and graphing lines because they will be important for us in the coming section. So a scatterplot is a way of displaying paired data on the same graph. And usually you think about it as one of the variables that are in the pairs as your independent variable. You're thinking that it's your input variable. And the other one is the dependent variable, that is your output variable. And we usually put the independent variable, the one that affects the other variable, we usually put that on the x-axis. And the dependent variable, the one that's affected by the other variable, that goes on the y-axis. Now, sometimes these choices aren't completely cut and dry, but if it's possible, you do want to choose an independent and a dependent variable carefully. So let's look at this situation. So let's say we're interested in graphing ice cream sales and temperature on one graph. And I should say temperature on a particular day. So the ice cream sales and temperature on a particular day on the same graph. So for example, maybe on one day it was 29 degrees Celsius and there were 150 ice creams sold that day. So quickly think about which of these two variables, ice cream sales and temperature, which is the independent variable and which is the dependent variable. Which one affects the other? Does temperature affect ice cream sales, or does ice cream sales affect temperature? Okay, so it should be pretty clear that temperature affects ice cream sales. So the independent variable here is going to be temperature, and that's what we're going to put on the x-axis. And our dependent variable is going to be ice cream sales, and that's going to go on the y-axis. So let's label these. This is going to be temperature in degrees Celsius, and our y-axis is going to be ice cream sales. So let's say we have the following 3 points we want to graph: 29 degrees, 150, 15 degrees, and 70, and 22 degrees, and 110. So let's say we have those. So it looks like our temperature goes between, I don't know, goes up to 30, we'll say. So maybe let's put in some markings here: 10, 20 degrees, 30 degrees. This is just a sketch. If I was doing this professionally, I would be a lot more accurate. And maybe on our y-axis, it looks like we're going up to 150. So maybe I will go up by 50s here. So this is 50, 100, and 150. Okay. So let's do the first point. Maybe we'll do that in blue here. 29 degrees and 150. And usually we put commas between these numbers, actually, just so it's clear where the first number starts and the second number begins. So that is, we go to 29 on the independent axis and 150 on the dependent axis. So it would be somewhere around here. There's the point 29, 150. The point 1570 would be somewhere around here. You can see we're at 15 degrees Celsius and about 70 ice cream sales here. And finally we have 22, 110. So that would be right about here. So that looks like 22 on the x-axis and about 110 on the y-axis. So that's what a scatterplot is. It's a good way of graphing two variables paired to the same experimental unit on the same graph. Okay, a quick review of straight lines. Remember, a straight line has an equation y equals mx plus b, where m is your slope and b is your y-intercept. But just for this course, and in statistics really in general, when we're talking about lines in the context that we're going to be talking about them, we usually use b1 for the slope and b0 for the y-intercept. And that's because we can generalize this idea in future stats classes where we'll have something more complicated than just a term with an x, a linear term with an x and a constant here. So we're just going to call this b1 is our slope and b0 is our y-intercept. And remember, slope is just your change in y over your change in x. It tells you how many units to move up or down in the y direction as you move 1 over in the x direction. Okay, so let's do these two quick examples. Maybe a good idea for you guys is to pause the video now and try these. Just quickly graph y equals 2x minus 1 on a Cartesian coordinate system. And secondly, graph the line containing the points 3, 1 and 2, negative 2, and then quickly find its equation. So pause the video now and make sure that you can do that. Okay, now that we're back, so I have the line y equals 2x minus 1. I'm going to graph this in, let's say, green. So here is my y-intercept. So I know it cuts the y-intercept, or it cuts the y-axis at y equals negative 1. So there's negative 1 there. And then the slope says, okay, for every unit you go over in the x direction to the right, you go up 2. So I'm going to go over 1 unit and then up 2. So that takes me to the point. So this is the point 0, negative 1. And this is the point 1, 1. And once I have 2 points, I can just join them up, and there's my line. Alternatively, you could just pick 2 x values, whatever x values you like, really. Plug in x into those, figure out what the y is associated to that x, and then you would get 2 points out of that, and draw a line. That's another way of doing it as well. For example, maybe you wanted to pick the point x equals 2, then you'd get y is 2 times 2 minus 1, which is 4 minus 1, which is 3. So you'd have the point x equals 2, y equals 3 on your line, and in fact that is right here, 2, 3. Okay, so, well, the first part of B is very easy. Graph the line containing the points 3, 1, and 2 minus 2. So let's go ahead and do that. So 3, 1, I'm going to go over 1, 2, 3 on the x-axis, and I'm going to go up 1. So there is the point 3, 1. And 2 minus 2, I'm going to go over 2, 1, 2, and I'm going to go down 2, 1, 2. So there is 2 minus 2, and I can join those, and there's my line. Okay, and quickly, let's indeed find the equation of this line. So we can find the slope first. So remember, the slope is the change in y over the change in x. So our slope, b1 of our red line, is going to be, well, how are the y values changing? Well, you're going from 1 to minus 2. So we'll subtract those, 1 minus a minus 2, over our x values. So we're going from 3 to 2. So we're going to do 3 minus 2. So we get 1 minus minus 2 is 3, and 3 minus 2 is 1. So our slope is 3. We're kind of lucky in some sense that our slope is an integer. It doesn't have to be an integer. You can have slopes of any type of number, fractions, decimals, whatever. But this is a nice slope to work with. Okay, let's find our y-intercept. We know our equation looks like y equals 3x plus b0. So we can plug in any point we like on our line, and that will give us our y-intercept. So let's plug in, I don't know, 3, 1. We have that point floating around. We know the point 3, 1 is on our line. So we know the y value is 1, and that equals 3 times our x value 3 plus b naught. And what do we get? We get 1 equals 9 plus b naught. Subtracting 9 from both sides, we get that -8 equals b naught, or b0. So our equation, which I will just write next to our line here, is going to be y as 3x minus 8. And that makes sense. We can see that our red line is steeper than our green line, so the slope is bigger. And it looks like if we continued this red line down as far as we need to reach the y-axis, it probably would intersect the y-axis at -8. So this jives with our graph. We're pretty happy with this.